This video is over comparing functions which are represented in the same form, in this case graphs. Pictured, we have three different graphs to look at. Our quadratic curve is the black function that we're going to call f of x in this case. We know that's quadratic because it has a u-shaped curve. Our green function is an exponential curve, which we're going to call g of x. We know it's an exponential curve because it's a j-shaped curve and it is decreasing exponentially, appearing to go to an asymptote. Our straight line, our blue line, that is a linear function. We can tell again because it's a straight line. We're going to call that function h of x. Now let's compare these functions represented in the same way. Which function has the greatest x-intercept? If we look at our graphs, we're going to have to find the x-intercept of each one. The x-intercept of the blue function, h of x, is -2, 0. The x-intercept of f of x, our quadratic function, is 0, 0. The x-intercept of g of x doesn't exist. Since this function has an asymptote, it never actually touches the x-axis. So our function with the greatest x-intercept is f of x. Which function has the greatest y-intercept? In this case, we're going to be looking at our y-axis instead. Let's take a look at those. Right now, our f of x function has a y-intercept of 0, 0. And it looks like g of x and h of x have exactly the same y-intercept at 0, 1. So which function has the greatest y-intercept? We could say g of x and h of x. They both cross at 0, 1. Now let's move on to our next comparison. List the functions in order from smallest to largest when x is equal to 1. So from here on our x-axis, we're going to locate where x is equal to 1, which would be right here. And I'm just going to draw a line going all the way up and all the way down. From there, we're going to list the functions from smallest to largest, from least to greatest, depending on where they hit that line, that purple dashed line that we just drew. So our lowest value, our lowest y value when we are at x is equal to 1 is with this f of x function here. So f of x is the least, has the lesser y value when x is equal to 1. Our next function as we move up is g of x. That has our next largest y value. And the function with our largest y value at x equals 1 is h of x. Let's go ahead and do the same thing for our next question. This time we're looking to see who has the greatest y value when x is equal to 7. So we're going to draw that same line right along here where x is equal to 7. Now you notice our functions may change. This time, my smallest y value when x is equal to 7 belongs to g of x, our exponential function. Probably because it's getting so close to its asymptote. Our next largest y value when x is equal to 7 belongs to our quadratic function, or f of x. And if we go up further, our linear function h of x has the largest y value when x is equal to 7. Which functions have a positive rate of change throughout the entire graph? In this case, we're looking for which graph increases over its whole domain. And in this case, our function that's in blue, our h of x, is the one that does so. So the function with a positive rate of change throughout the entire graph is h of x. Which functions have a negative rate of change throughout the entire graph? So this means throughout the whole domain, negative infinity to positive infinity, which function decreases the entire time? If we look here, it's between f of x and g of x. F of x does decrease, but at the vertex, our turning point, it starts to increase again. G of x does decrease the entire time, has a negative rate of change. It is decreasing all the way to its asymptote, and even though it looks like we can't tell if it's decreasing there, if we were to zoom in on Desmos, we would still see it. So which functions have a negative rate of change throughout the entire graph? G of x does. Our next question, which function has a vertex? We know that the vertex is always with the quadratic function, and in this case, f of x is the one with the quadratic function, so that one has a vertex.